Suppose we wanted to evaluate this integral, and suppose we wanted to do it by our method of direct substitution. First of all, you're going to have to go through these steps, which can look quite daunting, but as you practice more and more, the steps will start to flow better from one to the other, and it'll become second nature to you, but it does require lots of practice. Before we actually get started with this, let's copy the problem back down again. Step 1 says to set u equal to the expression raised to the power. And as we've discussed, when there's any doubt in your mind about what to choose for u, a good rule of thumb for these type of problems is to choose the expression with the higher power of x. So there's only an x to the first power in the numerator, there's an x to the second power in the denominator, so that would be your natural choice for u. So we choose u to be x squared minus 6x plus 1. Step 2 says to compute du dx. That's the derivative of u with respect to x. That would be 2x minus 6. Then solve for dx. I would multiply both sides by dx. Notice on the left the dx is divided out, and you get du is the quantity 2x minus 6 times dx. Generally speaking, when you have a common factor in your differential, chances are you're going to need to factor out that common factor. Not always going to work that way, but most of the time it will. So I'm going to factor a 2 out of that and rewrite the differential du as 2 times the quantity x minus 3 times dx. And I can see that it was a good choice already because when I look back at the original integrand, there is an x minus 3 there. That makes me feel good about my choice of factoring that out. In any case, we're solving for dx, not du, so I need to multiply both sides by 1 over the quantity 2 times x minus 3, so that the 2 times the x minus 3's will divide out on the right, leaving me with dx being 1 divided by the quantity 2 times x minus 3, all multiplied by du. So I've solved for dx. Step 4 we don't need. There's nothing to factor out. There's no common factor that's a constant. Step 5 says to substitute both the u and the expression represented by dx into the integrand. So it's just a straightforward process. We let u be x squared minus 6x plus 1, so you simply put that u under the square root in place of the x squared minus 6x plus 1. Also, the differential's got to go. The dx we found by our calculation to be 1 over the quantity 2 times x minus 3 times du, so that comes out as du, and now it needs to be simplified. Notice that the x minus 3 in the numerator divides out with the x minus 3 in the denominator, and that's going to happen if you've done this correctly. Your x's and dx's have to come out of there. So when you simplify it, you also notice that there's a 1/2 factor that's shown up, and we can take that 1/2 and move it outside the integral. Remember, we can always take a factor that's a constant and move it outside of the integral sign if we like. So cleaning it up a little bit, the 1/2 comes out, the square root of u is in the denominator still, everything else is gone except for the du. Now we go back to our little knowledge of square roots. We know we're going to have to get powers into this problem because our general power rule for integration tells us how to do it with u to a power. So we want to get rid of the square root. So we change it to 1/2 power. Not only that, we don't want it in the denominator. We want to think of that 1 over u to the 1/2 as u to the minus 1/2. We're thinking ahead and we're trying to match this to the general power rule for integration. And now it's time to use it. The general power rule for integration tells us how to take the integral of u to a power. That's why we wanted to change the square root of u to u to the 1/2, and why we wanted to change 1 over u to the 1/2 to u to the minus 1/2 so that it would fit this power rule for integration. So now we're ready to use it, and it's going to require us to increase the power of u by 1. So we're going to take the minus 1/2 and add 1 to it. Well, minus 1/2 plus 1 is like minus 1/2 plus 2/2. That leaves us a positive 1/2. So when we add 1 to minus 1/2, that becomes a power of 1/2. But remember that 1/2 sitting out front has to be used as well. So I'm just going to copy it down and then do what I just said. Add 1 to the minus 1/2 to get a positive 1/2. And finally, the general power rule for integration says that we have to multiply by 1 over the new power. 1 over a number is just the reciprocal of the number. So 1 over 1/2 is 2. So we have to put a 2. And as always, with indefinite integrals, we have to put a plus c. Now we're sort of playing cleanup. 1/2 times 2 is just 1, so we end up with u to the 1/2 plus c. And the very last step says to substitute the x values back in, simplifying if needed. Remember, we put the u's in ourselves. They weren't in the original problem, so now they have to go. The u comes out, and the expression that it was equal to, which is the x squared minus 6x plus 1, goes in its place to give us our final result. And keep in mind, if you have any doubt that you got the answer right, all you have to do is take the derivative of what I've just boxed in there and convince yourself when you take its derivative, you get what you started with. You can always check these integrals by differentiating and see if you get what you started with. So if you end up with that answer, differentiate it and see if you get back the integrand that you started with. If you do, you know you got your integral right. In any case, there's your answer.